All right, you've watched part 1 of projectile motion, and now you've watched your YouTube video of the guy shooting the ball and dropping the ball at the same time. Did you see what happened? And did that surprise you? You should have seen that when you shot an object and you dropped an object, as long as it was shooting straight and you were dropping at the same time, they still hit the ground at the same time. What? One was going like this and one just dropped straight down. And yet they did this and they still hit the ground at the same time. You see, anytime an object is moving like that, if it's being shot, there's two forces acting on it. Or two motions in it. There's the motion horizontally this way, and then there's the motion this way. There's two sets of motion. Those two motions are completely independent of each other. This motion doesn't change the fact that it's falling. It falls just as fast as an object you just drop. Now, you got to be careful that you don't include lift in here, just like you have to ignore air resistance. Like an airplane, of course, has lift, and that's different. It's designed to use the air to fly. But if it's just like a round object and it just shoots this way, at the same time it drops, they fall at the same speed. It doesn't matter that it's moving this way. The gravity is still pulling it down at the exact same rate, at the exact same speed as if you just drop an object. This motion does not affect this motion. And this motion doesn't affect that one. It has a certain speed, so it travels a certain distance before it hits the ground. So you need to write this in your notes. When an object is shot or thrown, the horizontal motion this way is completely independent of the vertical motion up and down. They do not affect each other. This means if an object is dropped at the same time as a projectile is shot, both of them will hit the ground at the same time. Because this motion doesn't affect this motion. They're independent. It's falling. It may be moving that way while it's falling, but it's still falling. Crazy, right? Make sure you get this written down in your notes. You can pause this or you can go to your slides and get this written down. Now let's expand on this a little bit, because the last thing I want to talk about is what's called an orbit. You've heard of orbits before, like the moon is orbiting the Earth. Thus, the Earth is orbiting the sun. And we have things like satellites and spaceships that go up and orbit the Earth. It means it's going in a circle around the Earth and it's held there by the gravity. So let's take what we just talked about, this stuff, and see what does this have to do with an orbiting object. So we're going to go and talk about shooting an object again. This time, let's expand on this a bit. We're going to change our picture. And this is going to get kind of weird. Here's the Earth. You're standing over here. You shoot something like a gun. Move this forward just a tad. What does that bullet do, assuming you're shooting straight out? Because remember, if you shoot up, it does an arc, and so that's going to change it. If you shoot up and drop an object, they will not hit at the same time, because this one has to go up and then down. That's different. Also, if you shoot down, that one's going to hit the ground first, right? It's only if you're shooting straight. So let's say you shoot a bullet straight. Of course, it's going to go in an arc. It's going to go a certain distance, and then it's going to, let's move that up. It's going to hit the ground, right, in an arc. And if you were to drop a bullet at the same time, it would hit the ground at the same time, right? We talked about that. You drop a bullet at the same time you shoot it, it would hit the ground at the same time, but this one would have moved a long distance because it's going fast. But if it took 1 second for this to hit the ground, how long would it take for that to hit the ground? A second. 1 second. It would hit the ground at the same time. Okay? So now imagine that we take a more powerful gun that shoots a longer range, and you shoot it straight out. Boom. What's it going to do? It's going to go farther. It's more powerful. But how long will it take to hit the ground? 1 second, if we're using the same numbers. It's still going to hit the ground at the same time. The difference is it's traveling faster this way. So in that 1 second, it can go a further distance. It can go a greater distance in that 1 second. If you use something like a sniper rifle, those are really powerful. They send that bullet really fast. So in that 1 second, it can go really far before it hits the ground, but it would still curve and hit the ground. Now, some of you guys who do shooting and target practice, you're saying, wait, Mr. Dahl, this cannot be right. Because if I shoot something over there, I can shoot it, and it takes a while for the bullet to hit the thing, right? It's not the same. That's because usually when you're shooting or hunting or something or target shooting, what do? Do you shoot perfectly straight? No, you take your sights and you change them for your distance, which is going to cause you to shoot up a little bit. And that will cause the bullet to be in the air a longer time, okay? So be careful with that. We're talking about shooting perfectly straight. And if you shoot perfectly straight, every gun is going to work the same. It's going to hit the ground at the same time as if you dropped a bullet. Again, the only thing that's going to change that is a little bit of lift with the bullet from it spinning. So we got to factor that out. Now let's expand on this. This is showing the Earth as being flat. But of course, the Earth isn't flat. The Earth is round. So we're going to take this to the extreme. Now, for our purposes, it is pretty much flat when you're shooting a gun because they don't go that far. But now let's say here is the Earth. It's really not a very round Earth. Let me redraw that there. That's a little better. Here's the Earth. We're going to make you huge just for our demonstration purposes here. And now you shoot that gun. And we know that if you shoot it, it's going to go a certain distance and hit the ground. You drop the bullet. You get a more powerful gun, it goes a little further. You get a more powerful gun, it goes a little further. Now, what's happening here, if you theoretically had something going fast enough and the Earth was flat and there weren't mountains in the way, you would have to start to take into account the curvature of the Earth because the Earth isn't flat. So now you're increasing the distance that the bullet has to fall, right? So when you start accounting for the curvature of the Earth, the faster your bullet goes, now it starts to take longer to hit the ground. Again, this is in a hypothetical thing. This isn't going to happen in real life. But you can see that as it goes faster and faster, you get more and more powerful guns. Gravity's still pulling it down, but it starts to, as it's falling in that arc, the Earth is curving away from it. So it takes a while for it to actually hit the Earth. Now, theoretically, you get a gun that is so powerful that it's going so fast that as it falls to the Earth, it matches the curvature of the Earth. And the Earth is sort of running away from it because the Earth is curving away from it as the bullet falls. Theoretically, you get to the point, gravity's pulling it down, the bullet is falling in an arc, but the Earth is continually curving away from it, and so it can't ever actually hit the Earth. It can't catch it. And you end up hitting yourself in the back, right? That is what an orbit is. An orbit is an object that is actually falling to the Earth, but is moving so fast this way that as it falls, the Earth curves away from it. And so it never hits it. So it just keeps falling and falling. But as it's trying to fall and hit the Earth, it's going this way, and it doesn't ever actually hit. You see, there's two forces here. There's the motion of it trying to go this way. You can see the little velocity there. It's trying to go that way. Gravity's pulling it this way, so it moves in an arc. But the Earth is running away from it. The Earth is curving away from it. So when you have a satellite or a space station. What it's doing is it's going this way like a bullet. It's going really fast. You're going thousands of miles an hour. It's going really fast this way, and it would like to do this, by the way. It's what it wants to do. But gravity's pulling it this way, so it falls in an arc. But the Earth curves away from it before it can actually fall. Now, if you slow that thing down, yeah, it's going to crash into the Earth. And if you speed it up too much, it's going to escape the gravity and go in a straight line that way. So you got to get it just the right speed. But if you get it the right speed, it's falling and moving this way. And so as it falls to the Earth curves away from it. That's an orbit. The Earth is falling into the sun. It's moving this way. The sun is pulling its gravity down, and it's falling to the sun, but it never hits it because it's going too fast this way, so it just keeps spinning. Now, this is a pretty tough concept, and I understand that. You might want to watch this a couple times. You might want to do a little bit more research on orbits. But the key points here are, in this section, that if you shoot an object straight and you drop an object at the same time, if you're shooting straight, they will hit the ground at the same time. This motion is completely independent of this motion. They don't affect each other. And if you get it going fast enough, the curvature of the Earth means that the object will keep falling and falling and falling forever, and that's what an orbit is. It's an object that's just falling. But it never hits the thing it's trying to fall to. That's an orbit. Well, you've watched my first video. You watched that YouTube video about shooting objects, and now you've watched this video and taken some notes. The last thing you need to do today is I've put up another Mythbusters video where they test shooting a bullet and dropping a bullet. I'll give you a timestamp. I think this is a longer video. I'll give you a timestamp if you just want to watch the correct section. And if you have if it says it's restricted, we had that problem last time. It's just something on your end with your parents' controls. You can have them sort of allow you to see that video or something. Or just know that the video is going to show you what we talked about, right? They shoot a bullet, they drop a bullet, and they prove that they hit at the same time. It's a pretty cool video. I would watch it. Okay, Wednesday, we have a quiz, open notes, open videos. So make sure you maybe watch these things a couple times. It'll be everything gravity and projectile motion the last week and a half. And so you'll want to be ready for that. Okay, thanks everybody, and I'll see you later.